Thanks to this tiny electronic component, your electronic devices run smoothly without fluctuations. An inductor ensures the steady flow of current. Inductors come in different shapes and sizes, like the toroidal inductor, a donut-shaped core with a wrapped coil, the multi-layer chip inductor, multiple layers of coiled conductive traces on a ceramic substrate, and the ferrite core inductor, manufactured with a ferrite core inside the coil known as the ferrite core inductors. Though there are many types, we'll focus on the ferrite core inductor to understand its working. But before diving in, let's explore some governing laws. Ampere's law, Faraday's law of electromagnetic induction, and Lenz's law. Ampere's law states that when an electric current flows through a wire, it creates a magnetic field around it. Observe this using a compass. The needle will align with the magnetic field. When a magnet approaches the coil, changing magnetic flux induces a current, creating a magnetic field opposing the magnet. Similarly, moving the magnet away causes a change in magnetic flux, inducing a current that generates a magnetic field, again opposing the magnet's field. Faraday's law of electromagnetic induction explains that a change in the magnetic field around a wire coil induces an electromotive force, EMF, or voltage across the coil. This induced voltage can generate an electric current in a closed circuit. Lenz's law complements Faraday's law by indicating that the induced current flows in a direction opposing the change in the magnetic field. For instance, when the magnet approaches the current-carrying coil, it induces a current that generates a magnetic field opposing the external magnetic field, oriented from left to right in this scenario. Similarly, as the magnetic is displaced, the coil induces a current that produces a magnetic field opposing the external magnetic field, with the induced current moving from right to left. Now, let's explore how the inductor works. In this setup, the inductor is connected in parallel to an LED and a battery. When the circuit is closed, the inductor initially resists the current flow. The resistance occurs because, according to the mentioned laws, the current through the inductor produces an opposing electromotive force, EMF. After some time, the induced magnetic field reaches its maximum. At this time, the internal resistance of the inductor is almost zero, and consequentially, the current flows directly through it, creating a short circuit. When the circuit is opened, the stored magnetic field in the inductor transforms into electrical energy. This energy encourages the flow of electrons for a short duration. This process illustrates how the inductor interacts with the circuit, resisting and releasing energy when the circuit is opened. This property makes the inductor a crucial device in our daily electronic devices. Electric motors power various devices, including drones with rotors made of electric motors, industrial machinery, and household devices such as blenders and mixers that operate using motors. Inductive cooking. Inductive cooking sends electric currents through the coils beneath the cooktop, creating a magnetic field that heats up magnetic cookware efficiently. Wireless charging. Inductive charging is used in wireless charging pads for smartphones and electric toothbrushes. Placing the device on the pad induces current in the receiving coil, charging the battery. Inductors are crucial components in electronics, playing a vital role in our daily lives.